Good evening, dear students. Let's start our class on circle. That is in continuation of whatever we have discussed in previous sessions. And today we will start with concentric circles. Now, before I proceed further, could you please confirm that you are able to view the screen properly and able to hear my voice very clearly?
Yes,
Okay, great. Thanks for the confirmation. So, as the word concentric, it signifies that, and circles, the plural number, that is that there are many circles with the same center. Okay. For example, what that we can have, suppose this is a center, and we can have a circle something like this. Though it doesn't look like a circle, and then this is another circle, and then this is another circle. Correct, dear students? What I wanted to mean is that the way I have drawn it doesn't look like a proper circle, but you understand that it is, my intention is to draw circles. So now all these circles, as you see, they have, a common center. Suppose this is the center C, and then why they are varying? They are varying in their radius. So suppose this is one radius, this is another radius, this is another radius. So now as their center is same, center is common. If you recall, the general equation of a circle is what? X square plus y square plus 2gx plus 2fy plus c is equal to 0. That is the general equation of a circle. Now, in this general equation of this circle, what is the coordinate of the center? The center is having the coordinate, minus comma minus f. That is the center. The center is actually minus g comma minus f. Correct? Now, as you see, for all these circles, this is a family of circles with the same center, having the same, coordinate of the center as minus g comma minus f. That means whatever the equation of the concentric circles we are going to form, then all these first four expressions would be same. X square plus y square plus 2gx plus 2fy, that will be same. Because if I write like this, that x square plus y square plus 2gx plus 2fy, the moment I complete writing this, it says that yes sir, you are writing the equation of a circle. It hopes that you started writing the circle, and so far whatever you wrote, with this I can say the center of the circle is at the point minus g comma minus f. After that I add one constant called c, that is equal to 0. Then if I write another circle something like this, x square plus y square plus 2gx plus 2fy plus lambda equal to 0, then you see, dear students, these two circles are concentric circles, isn't it? Because c and lambda, they actually differ. They actually tells that what is going to be the radius. Okay, so these two are concentric circles. So that is what I wanted to discuss first. Next point what I'm going to discuss, dear students, is that we are going to discuss with circle with center at a point h comma k, suppose, and which touches the axis of x. After that we will discuss about when it is touches axis of y. Then we will discuss when it touches both the axes, okay, both x and y axis. So the next point what we are going to discuss, dear students, is the circle with which center at point h comma k, which touches the axis of x. Let me go to the next page and discuss about this. So let us first visualize this statement what I wrote here. Okay, that circle with center at the point h comma k and which touches the axis of x. So if we start visualizing this, so what will be our circle? So suppose the circle I'm going to draw first now. Suppose this is the circle. And now what I'm going to do, I'm going to just, which touches the axis of x. So suppose this is x-axis and this is y-axis, correct? And this is the center. So if this is origin, then this is x-axis, this is x dash, this is y, this is y dash. Okay. And what is the center? Center is at the point C with coordinate h comma k. Correct. Now, if you look into this particular circle, that entire representation is actually, entire visual representation is actually the statement what I wrote. Now, how to find that equation of this particular, circle? Now, the way to proceed is that we know that the center of the circle is what? H comma k. So definitely its equation will be x minus h whole square plus y minus k whole square, correct? And then the radius will be what? Radius will be, h, sorry, radius will be k, correct or not? If you see that y coordinate is going to be the radius, so that means this one. So if I draw it in a different color, so this particular, is going to be the radius what I draw in the blue color, and that value is actually, k. So what we can write here, dear students? So we can write this is equal to k square. So now if we simplify further, what we are going to get? We are going to get x square minus 2hx plus h square plus y square minus 2 into k into y plus k square is equal to 0. Sorry, is equal to k square. Now k square in the right hand side and k square in the left hand side got cancelled. So what the equation we are going to get, dear students? X square plus y square minus 2 into h into x minus 2 into k into y plus h square is equal to 0. This is the equation of the required circle, which having center at h comma k and touches the x-axis. I hope it is clearly understood. Now let me go to the other one, the circle with center at the point h comma k and which touches the axis of y. And let's see how it will looks like. I hope you understood actually, but it is just the way I have done for the x-axis. It is going to be in the similar manner, right? But still, let me show you how it will look like. So here the point of discussion is that circle with center at the point h comma k and which touches the axis of y. So let me first construct the circle, and let me first give a visual representation. So let me use in a different color, dear students, here. So if you look into this one, so and then I'm going to draw the y-axis first because it is touching the y-axis. Now, if we see that this is a center, that is C, with coordinate h comma k, and what we see, dear students, is that it touches the y-axis. So now, as it touches the y-axis, so we can find that what is the radius of this. So radius of this will be h, correct or not? So this is h, what I draw in the blue color, that is h. So what is the equation of that circle? What we can write here, dear students, is something like this. The equation of the circle here, it will be, as the center is at the point h comma k, so x minus h whole square plus y minus k whole square is equal to h square, because this one is h. So that implies what? This implies x square minus 2 into h into x plus h square plus y square minus 2 into k into y plus k square is equal to h square. Now h square in the right hand side get cancelled with h square in the left hand side. So we get x square plus y square minus 2hx minus 2ky plus k square is equal to 0. This is the equation of the circle which touches the y-axis and having center at the point h comma k. So I hope it is very well understood. Now the next point, dear students, what we are going to discuss is that the circle which touches both the coordinate axes, and let's see how it is going to happen. What kind of situations we can get. So let me go to the next page and let me explain this thing. So here, dear students, that let us take the A be the radius of the circle, and each touches both the coordinate axes. So let me first draw the coordinate axis first. Okay. So if I draw the coordinate axis first, so now the circle what we are going to construct, it touches both the coordinate axes. So what will be the picture will be looks like? It will be or I can do one thing. So it will be something like this. Let me first present it here, so that will be more accurate here. Okay, please have a look into this thing. So this is a clear representation of that statement, the circle which touches both the coordinate axes. So the four circles what you see, dear students, here, both are having all these, not both, the four circles, they are having the center in four different quadrants, right? So here what we observe, dear students, is that if we consider A be the radius of the circle, since the center of the circle may be in any of the four quadrants, therefore it will be any of the 4 points. So what will be the coordinates of the center? So the coordinates of the center, okay, so if you see, the coordinates of the center could be either a comma a, or it can be, minus a comma a, or it can be minus a comma minus a, or it can be a comma minus a. So any of these four combinations possible. So if we represent all these things together in a shorter manner, we can write plus minus a plus minus a. So what we see, dear students, that plus minus a comma plus minus a is the coordinate of the center of the circle, and it depends on the which quadrant it is. Thus, so we get there are four circles of radius a touching both the coordinate axis, and hence as there are four circles, we will get four equations, correct or not? So what are the four equations? That we are going to find it out, and that also, the way we can, if we see that first equation, so what it will be, this circle's equation will be x minus a whole square plus y minus a whole square is equal to a square, correct, is equal to a square. If you look into this one, that will be x minus of minus a, that is x plus a whole square plus y minus a whole square is equal to a square. Third one you will get is that x minus minus a, that is x plus a whole square plus y minus minus a, that is y plus a whole square is equal to a square. And in the fourth one, what we see is that it is x minus a whole square plus y minus minus a, that is y plus a whole square is equal to a square. So what we see, dear students, so these are the four different circles, and how you can represent it in simple manner. So the way we can represent it is something like this: x plus minus a whole square, correct now, plus y plus minus a whole square is equal to a square. Or if you can make it more simpler manner, so what we can get is that we can write that x square plus y square plus minus 2ax, okay, plus minus 2ay plus a square is equal to 0. Now, if you see that equation, what I just marking within the red box is that you can take a combination of plus and minus. You can take plus plus, plus minus, minus plus, and minus minus. So when you take all these combinations, you will get four different equations. So this is about the circles with touches both the coordinate axis, and we discussed this thing. I hope it is well understood, dear students. Never hesitate to let me know if you have any smallest doubt. Okay. Now the next point what I'm going to discuss, dear students, is about the a circle and a point. That how a circle and point are relatively positioned. That means what? That means is that if I give you an equation of a circle, and if I give you a point, if I give you a point means if I give you the coordinates of a point, then can you tell whether the point is outside the circle or on the circle or inside the circle? This is the point we are going to discuss now. So the topic of the discussion is that circle and point. So let us first visualize this problem. Okay, to visualize this problem, first let's draw the this. Suppose this is a circle, and we have a point. Suppose this is the point. A point could be either here, or here, or it could be here. There are the three different positions. Okay. Now the equation of the circle is given to us. What is the equation of the circle? So suppose the equation of the circle is x square plus y square plus 2gx plus 2fy plus c equal to 0. So this is the equation of the circle. Okay. And what is the point? Suppose the point is A with coordinate x1 comma y1. That point A could be here also, dear students. Okay, means on the circle, or it could be here also, or it could be here also. We do not know, but we know one thing, that the coordinates of the point is given, and all these are given by means of numbers. So unless you precisely draw the circle in a graph paper, or precisely give the coordinate of point that in the graph paper, you really cannot say. But we are going to do without doing that graph. Okay, we just doing that algebraic method. We are going to conclude whether the point is outside the circle, on the circle, or inside the circle. How to achieve that one? So now we know, as this is the equation of the circle, so what is the coordinate of its center? Okay, the coordinate of the center is at the point minus g comma minus f. Correct, dear students? The coordinates of the center is at the point minus g comma minus f. Now that point A, okay, so suppose we see that this is a C, that center of the circle with coordinate minus g comma minus f. Now what we are going to do, we are going to find the distance between C and that A. What is the distance between C and A? So suppose we define that distance between C and A, that is equal to D. Now that means what, dear students? So what will be the value of D? So the value of D should be equal to x1 minus of minus g, that means x1 plus g whole square. Correct? x1 plus g whole square plus y1 plus f whole square. Correct? So that is the value of D, isn't it? So now what is R, dear students? R, if you remember, that is equal to g square plus f square minus c. So R is equal to square root of actually g square plus f square minus c. Now what we are going to find, dear students, is that d square minus r square. Why? Why we are going to find it out? So A will lie inside. So if we find that if A, one thing, let me write it here, that if A lies inside the circle, D should be less than R. Correct or not? Obviously, suppose the point is here is A, so this is the distance, so which is definitely less than the radius. So D is less than R. That means what? That implies if D is less than R, that definitely means D square is less than R square. If A lies outside the circle, then D is greater than R. That implies D square should be greater than R square. Correct? And if A lie on the circle, if A lies on the circle, so what we are going to get? We are going to get D is equal to R. That implies D square is equal to R square. So when we say D square is less than R square, that means what? d square minus r square is less than 0? When you say d square is greater than r square, that means d square minus r square is greater than 0. And when we say d square equal to r square, that means d square minus r square is equal to 0. So we see, dear students, that the value of d square minus r square is of prime importance. And let's find how to find that value of d square minus r square. We already found d from here, and we already know r. So let's find d square minus r square. So if we compute d square minus r square, so that should be equal to what? x1 plus g whole square plus y1 plus f whole square minus r square, that means g square plus f square minus c. Let's compute it. So from here, if we compute, so this implies d square minus r square is equal to x1 square plus 2 into g into x1 plus g square plus y1 square plus 2 into f into y1 plus f square minus g square minus f square plus c. Minus or minus c is plus c. So plus g square minus g square will get cancelled. Plus f square minus f square will get cancelled. So then what we get, dear students? We get d square minus r square is equal to x1 square plus 2 into g into x1 plus 2 into f into y1 plus y1 square plus c. Now this is very important expression, and you know there is a easy way of memorizing this expression. So you know the equation of the circle, what? Equation of the circle is x square plus y square plus 2gx plus 2fy plus c. Okay, so anyway, let me do one thing. Let me make it a more proper manner. Okay, just to in the similar manner of equation of the circle. So from here we get d square minus r square is equal to x1 square plus y1 square plus 2g into x1 plus 2 into f into y1 plus c. So this is the value of the expression d square minus r square. Okay. Now, if you recall what is the equation of the circle? What was the equation of the circle? We took x square plus y square plus 2gx plus 2fy plus c. And what you see, d square minus r square is x1 square plus y1 square plus 2gx1 plus 2fy1 plus c. That means in the expression of that x square plus y square plus 2gx plus 2fy plus c, we just replace x by the x coordinate of the point and y by the y coordinate of the point and conclude where what is the then we find the value of this expression and then we conclude. So if we get that this value could be what? Either less than 0, then we can say point is inside the circle. Now next one is that is equal to 0. Point is on the circle. And then the next one is that greater than 0, that point is outside the circle. Got it? Very clearly, dear students. Now, let's take a representative example so that to make sure that we understood it absolutely clear. Okay. The question is that how are the points? So let me place this question in front of you. and then followed by its discussion. So here the question is, how are the points 0, 1, 3, 1, and 1, 3 situated with respect to the circle x square plus y square minus 2x minus 4y plus 3 equal to 0. Task is very simple, dear students. What is that? We are going to find the value of this expression. That means what? X square plus y square, sorry, minus 2x minus 4y plus 3. We are finding the value of this expression when x is equal to 0 and y is equal to 1. If we find that value, so it will be what? 0 square plus 1 square minus 2 into 0 minus 4 into 1 plus 3. So that is equal to minus 6 and plus 4. That is actually, we are getting it as a, 0, 1. So x is 0, 1, minus 2 into 0, minus 4 into minus 2x minus 4y plus 3. Yes, so what we get? 3 plus 1 is 4, 4 minus 4 is 0. That is equal to 0. So then what we can conclude? This implies the point 0, 1 is on the circle. Correct, dear students? Is on the circle. Now in the similar manner, we need to find the value of the expression at the point 3, 1. Let me use a different color. Suppose we are going to find the value of the expression x square plus y square minus 2x minus 4y plus 3 at the point 3, 1. Then what we are going to get, dear students? 3 square plus 1 square minus 2 into 3 minus 4 into 1 plus 3. So here we are going to get this is equal to 3, 9, 1, 10, 10 plus 3, 13. It is 13 minus 6 minus 4 is 10. That is equal to 3, which is greater than 0. Now as it is greater than 0, very clearly we can say that 3, 1 is outside the circle. Correct, dear students? Now another point is that is the last point is 1, 3. So let me use a different color for 1, 3. Let me use this one. So here also you'll find x square plus y square minus 2x minus 4y plus 3, and we are going to find the value of this expression when x is equal to 1 and y is equal to 3. So 1 square plus 3 square minus 2 into 1 minus 4 into 3 plus 3. So this is equal to 1 plus 3, 9 plus 1, 10, 10 plus 3, 13, 13 minus 14. That is equal to minus 1, which is less than 0. As it is less than 0, so we can conclude the point 1, 3 lies inside the circle. That implies 1, 3 is inside the So anyway, to be grammatically correct, I should write lies. Here I should write 3, 1 lies, and here I will write 0, 1 lies. Okay. So now, as a side discussion, what I can say, dear students, that whenever you see that x square plus y square plus 2gx plus 2fy plus c, and we are just substituting the value of a point, coordinate of a point, x coordinate in terms replaced by x and y coordinate replaced by y, and we are finding the value of that expression. That also we will see used several times in circle, parabola, ellipse, and hyperbola in great manner. So all these things you'll able to see that it is going to be a very prime importance. Now, dear students, what I'm going to discuss is that I'm going to discuss the a point, a circle and a line. That how a line and a circle are relatively positioned. Before I'm going to the discussing the next topic, one thing you must understand that whatever we are doing here to conclude whether the point is inside the circle, outside is on the circle, or outside the circle, we are all doing using the algebra. We are not constructing the circle, in exact manner in the graph paper, or we are not, place that particular point based on the coordinates. Whatever the diagram we have drawn, that is a kind of a symbolic representation. It is not accurate representation. Okay, but whatever the conclusion we are making with all by means of this algebraic evaluation of these expressions. So now let me proceed to discuss on the next topic, that is called the that how a circle and a straight line and a line are positioned. Okay. So in the previous topic, a equation of a circle is given and the coordinates of a point is given. And here, dear students, the equation of a circle is given and the equation of a line is also given. And then we need to decide whether the line is actually not touching the circle, or touching the circle, or intersecting the circle. Now, whatever I said in the last 30 seconds, let me give you a visual representation. Okay. So for that, let me first, draw the circle. Suppose, this is the circle. And now we are going to have three straight lines. Okay. The first straight line, let me draw in the green color. Okay. And the second, suppose we give this straight line as L1. The second straight line I'm going to draw in suppose in blue color, and this is the straight line. Suppose I give this name of this straight line as L2. And now let me draw the another straight line, suppose, and this is the straight line, and we give name of this straight line as L3. So there are three straight lines, L1, L2, L3. And the circle is fixed. And if you notice carefully, dear students, that the straight line what I draw in the green color is actually not touching the circle and not intersecting the circle at all. It is completely outside. Now, if you look into the second straight line which I draw in the blue color, that is L2, you see it is actually just touching the circle at a single point. Obviously, when it is touching, it is a single point. And this is the point, if you see. This is the point. And if you look into the straight line L3, okay, and if you notice that the straight line L3 intersecting the circle at two distinct points. Now the point is that if the equation of the circle is given to us and the equation of the straight line is given to us, how we can determine whether the straight line is not touching the circle or not intersecting the circle, or it is touching the circle, or it is intersecting the circle. And that is the point of our discussion, dear students. And to have this discussion, so what we are going to do, dear students, is that, for the ease of our calculation, let's take the circle with center at the origin. You may think, no, sir, it may not be possible always the center, circle at the origin. No, not a big deal. We can shift the origin, okay, and and then we can do this thing because we know how the translation happens. We discussed in the points and straight lines. But anyway, keeping that discussion aside, so let us consider the equation of the circle is something like this. That is x square plus y square is equal to a square. So that means it is a circle which center at the origin and having the radius a units. And the straight line, the line equation of the line, let's take it as y equal to mx plus c. Clear, dear students? So we have these two. So equation of the circle, so let's keep this as equation number 1. And equation of the line y equal to mx plus c, we give this as equation number 2. Now, dear students, that we are going to solve these two equations. If you see equation 1, it is a quadratic equation. And if you see equation 2, it's a linear equation. So let us solve this thing. So what is the value of y? Value of y in the second equation, we get y equal to mx plus c. Now that value of y, we are going to apply in the equation 1. So then equation 1 will be something like this. This will imply that x square y equal to mx plus c whole square is equal to a square. So this implies what? This implies x square plus m square into x square plus 2 into m into c into x plus c square is equal to a square. Correct, dear students? So now let us express this one, represent this one as a quadratic equation in x. So then what we are going to get? So this implies 1 plus m square into x square plus 2 into m into c into x plus c square minus a square is equal to 0. Correct, dear students? Now, we are going to find the discriminant of this quadratic equation. Why we are going to find the discriminant of the quadratic equation, dear students? Because if the quadratic equation, what you see, suppose we give this name of this quadratic equation as 3. If this quadratic equation giving two distinct values of x, that means if this quadratic equation has two distinct roots, we can say that we get two different values of x. That means that straight line is intersecting the circle at two different points, like that L3. If we get the quadratic equation is having repeated roots, that means what we can say, that it has both the values of x are same. That means it is actually just touching the circle. That means the line L2. And if we find that there is no real values of x for this quadratic equation, we can say that this line is not at all in contact with the circle. Okay, forget about intersecting. It is not touching at all. That means it is like a state L3. So now how to find whether the value of x in the quadratic equation is real and distinct, or equal, real and equal, or they are imaginary? The best way of finding is the discriminant, right? Because that is the nature of the roots of a quadratic equation. Discriminant, determines the nature of the roots of a quadratic equation, isn't it, dear students? So, as this is the case, what we are going to do now, we are going to find the discriminant. So, discriminant, we are going to find it now. Discriminant, and that we define as delta. Okay, so what is that? B square minus 4ac. So that means B is what? 2mc. B is nothing but coefficient of x, b square, minus 4 into a into c. So 4 into a means 1 plus m square, into c, that is c square minus a square. Correct or not? I hope it is well understood. Now, there are three cases. What is the case 1? That there is no real point. If there is no real point of intersection, so case 1 will be what? So let me write it down here. So case 1 is no real point of intersection. That means based on our symbolic representation in that it is like a straight line L1. Okay. So if no real point of intersection, then what we are going to get? This delta has to be less than 0. Delta has to be less than 0. Delta less than 0 means what, dear students? That means 4m square c square, 4m square c square minus 4 into 1 plus m square into c square minus a square is less than 0. That implies what? That implies m square c square minus 1 plus m square into c square minus a square is less than 0. That implies m square into c square minus c square minus m square c square plus a square plus a square m square is less than equal to 0. Correct, dear students? So from here what we are going to get? You see that m square c square minus m square c square got cancelled. We can cancel these two. So from here what we are going to get? We are going to get is that a square into 1 plus m square, a square into 1 plus m square is less than c square. A square into 1 plus m square is less than c square. That implies a square is less than c square by 1 plus m square. Correct or not? So that implies that, so from here what we can say is that if a square is less than c square by 1 plus m square, that means we can say a is less than mod of c by square root of 1 plus m square. Okay, so this is the required condition so that the so that point so that the straight line has no real point of intersection to the circle. Correct, dear students? Now the next point what is coming is that the case 2, that is that when delta is equal to 0. Now, so there are two coincident point of intersection. That means it is touching the circle. Okay. And the case 3, what we are going to get is that when delta is greater than 0, then it is actually, that there are two intersecting points. Correct? So now, what we are going to do, dear students, now is that the case 2, discussion of the case 2. So let me write it down properly. There are two coincident points of intersection. There are two coincident points of intersection. Okay, so let us discuss this thing. In this case, what will happen? As we just said, the delta has to be equal to 0. Now, delta is equal to 0 means what, dear students? Delta equal to 0 means, 4m square c square, 4m square c square minus 4 into 1 plus m square into 1 plus c square is equal to 0. And dear students, I am not deriving each and every steps, because we have already done this kind of simplification just in the case 1. So what we are going to get is that we will get a square into, sorry, let me write properly, a square into 1 plus m square should be equal to c square. So that implies what? That implies we are going to get a is equal to, so from here what we get is that a is equal to c square by 1 plus m square. So from here what we are going to get is that this implies a is equal to mod of c by square root of 1 plus m square. So from here what we can say, dear students, c is equal to plus minus a into square root of 1 plus m square. So this is the required condition of tangency. That means when the straight line is a tangent to the circle. Correct, dear students? And also we can find the equation of the tangents. So you'll find there are two equations. So what are the equation of tangents? The equation of the tangents is that y equal to mx plus c, dear students. So this is the required condition for tangency. This is the required condition for tangency. And what are the equations of the tangents? Equations of the tangents are, there will be two equations. Y equal to mx plus c, y equal to mx, if we take the plus value of c, that is a into square root of 1 plus m square, and if we take the minus values of c, that is y equal to mx minus a into square root of 1 plus m square. You may think that how it is possible to have two different tangents. So it is we will discuss it later, and from an external point you can have two different tangents. Anyway, that we'll discuss later, some other class. Now let us concentrate on the case 3. Case 3 is that that when there are two different real points of intersection. Okay, so in this case what we are going to get it, so let me write it down, dear students. So here it is, case 3. Case 3 is that sorry, here is, there are two different real points of intersection. There are two different real points of intersection. Real points of intersection. Let us understand this case. Obviously, dear students, so here you will get delta is greater than 0. Delta greater than 0 means what, dear students? That means 4 into m square into c square minus 4 into 1 plus m square into c square minus a square is greater than 0. Correct, dear students? So from here I am not doing all the intermediate steps because I have already done in the case 1. So I can directly write, dear students, is that a square into 1 plus m square is greater than c square. That implies what? That implies a is greater than mod of c by square root of 1 plus m square. Correct? So then what we can say is that, if we have that, straight line, we are going to have two distinct point of intersection. So that is, I hope it is well understood that what are the different, conditions that with which we can conclude that that whether the straight line is not touching, or the straight line is touching, or straight line is intersecting a straight line. Okay. So with this note, dear students, I would like to conclude the class for today. And in the next class, we will, discuss some new topics on circle. But meanwhile, I will suggest you to please start working on solving the DPPs. Thank you very much.